So sometimes when we solve an equation, we don't have a simple equation like cosine theta equals some number. Now I might have cosine of 4 times theta equals a value, or cosine of theta over 2 equals some value. So I have to solve it in the same way, but I have to go a little bit further. So let's look at this example. I have cosine 2 theta equals negative 1/2. So the first thing I'm going to ask myself is, when is a cosine negative 1/2? Well, cosine is negative 1/2 in the second and third quadrants, and it's 1/2 at the pi over 3 family, so it's at 2 pi over 3 and 4 pi over 3. But that's not my answer, because that's what 2 theta equals. So now I know that 2 theta equals 2 pi over 3. And actually what I need to know is, I know it's plus some number times 2 pi, because every 2 pi of those it works. So I need to get theta by itself, so I divide by 2. So now I know that theta is 2 pi over 6 plus k times 2 pi over 2, which is pi over 3 plus k pi. Now I want to look for the answers for this, so I have to say, well, when k is 0, well then theta here is pi over 3 plus 0, or pi over 3. And when k is 1, then theta is pi over 3 plus pi, which is 4 pi over 3. Now I have to solve the other one. I have to say, well, when is 2 theta equal to, and I only have to go to 1 because it's 2 theta. If it was 3, I'd have to go in more. If I was to go to 2, I would get I'd be adding 2 pi, and that would be back to pi over 3. So 2 theta, when does that equal? 4 pi over 3, but I have to make sure I get all of them. So again, I'm going to say k times 2 pi, divide by 2, and it's 4 pi over 6 plus k 2 pi over 2, which equals 2 pi over 3 plus k pi. So here's my first two solutions. Here I'm going to look again. When k is 0, I have theta is just 2 pi over 3. And then when k is 1, I have theta is 2 pi over 3 plus pi, which is 3 pi over 3, so that becomes 5 pi over 3. So I have 2 more answers. So these are my 4 answers I need when theta is 2 pi.